The questions that we're working with in this video are called vector style problems. A canoeist paddles due north for a distance of 5.5 kilometres before turning and paddling a further 6.2 kilometres on bearing north 28 west. We need to find the distance and bearing of the canoeist from a starting point. The first thing we notice is that this is not a right-angled triangle, but making some extra construction lines we can turn it into right-angled triangles. The distance d that we need to find out is in the large right-angled triangle ADC, but we don't know a lot of information about that triangle. We're going to start by looking at the smaller right-angled triangle BDC. We can use trigonometry here to work out distances x and y. To find x, the question involves the opposite and the hypotenuse. It makes it a sine question. The sine of 28 equals opposite x over hypotenuse 6.2. Rearrange and solve and we'll find that x equals 2.91. To find y, the question involves the adjacent and hypotenuse. It's a cosine question. The cosine of 28 equals the adjacent y over hypotenuse 6.2. Rearrange and solve, y is equal to 6.47. Now we can turn our attention to the large right-angled triangle to work out d. We know that the distance CD there is x, 2.91. And we can work out the distance from A to D because we know the distance y is equal to 6.47. If that's added on to the initial 5.5, we'll have the total distance from A to D equals 11.97. Now we can just use Pythagoras' theorem to work out d. D is the hypotenuse, so d squared equals 11.97 squared plus 2.91 squared. D is equal to 12.32. Finally, we have to find the bearing of the canoeist from her starting point. This means we are standing at the starting point. We have to find the bearing to her. That'll be given by angle theta in the diagram. To find theta, once again we're looking at that large right-angled triangle ADC, and we can say that tan of angle theta equals opposite 2.91 over adjacent 11.97. That'll give us that theta equals 13 degrees 40 minutes. The bearing is from the north, rotate 13 degrees 40 minutes towards the west. The next example says that after walking 550 metres up an incline of 20 degrees, the bushwalker finds that the gradient of the hill increases to 38 degrees for the final 320 metres. Our job is to find the height of the hill. If we extend lines out and down, we can see that the height of the hill is given by this distance here. All we need to do to work it out is to consider each of the two triangles separately. Work out the height climbed in the first pitch of the journey, x, and the height climbed in the second pitch of the journey, y, and add them together, and that'll give us the total height of the hill. So, looking at that first triangle separately, we can say that the sine of 20 degrees, because it's opposite and hypotenuse, sine of 20 degrees equals x over 550. Solve it for x and find out the height of the first pitch. Then look at the second triangle. Once again, it's opposite and hypotenuse. It's a sine question. The sine of 38 equals y over 320. Transpose it and solve it for y, and we have the height of the second pitch. The total height of the hill can be found by adding together x and y. The height is 385.12 metres.